Now, at the beginning of the course, I promised you that we would be solving a hard SQL challenge together at the end of the course. So here it is. Let us try now to solve this challenge, applying the concepts in this course. Now, as a quick disclaimer, I'm picking a hard challenge because it's sort of fun and it gives us a playground to showcase several concepts that we've seen in the course, and also because I would like to show you that even big, hard, scary challenges that are marked as hard and even have advanced in their name can be tackled by applying the basic concepts of SQL. However, I do not intend for you to jump into these hard challenges from the very start. It would be much better to start with basic exercises and do them step by step, and be sure that you are confident with the basic steps before you move on to more advanced steps. So if you have trouble approaching this problem or even understanding my solution, don't worry about it. Just go back to your exercises and start from the simple ones and then gradually build your way up. That being said, let's look at the challenge, Marketing Campaign Success Advanced on Strata Scratch. So first of all, we have one table that we will work on for this challenge, Marketing Campaign. So Marketing Campaign has a few columns and it actually looks like this. Okay, so there's a user ID, created at, product ID, quantity, price. Now, when I'm looking at the new table, the one question that I must ask to understand it is, what does each row represent? And just by looking at this table, I can have some hypotheses, but I'm actually not sure what each row represents. So I better go and read the text until I can get a sense of that. So let's scroll up and read. You have a table of in-app purchases by user. Okay, so this explains my table. What does each row represent? It represents an event that is a purchase. Okay, so it means that user ID 10 bought product ID 101 in a quantity of 3 at the price of 55, and created that tells me when this happened. So this happened 1st of January 2019. So great, now I understand my table and now I can see what the problem wants from me. Let's go on and read the question. So I have a table of in-app purchases by users. Users that make their first in-app purchase are placed in a marketing campaign where they see call to actions for more in-app purchases. Find the number of users that made additional purchases due to the success of the marketing campaign. The marketing campaign doesn't start until 1 day after the initial app purchase. So users that made one or multiple purchases on the first day do not count, nor do we count users that over time purchase only the products they purchased on the first day. All right, so that was a mouthful, okay? So this on the first run, it's actually a pretty complicated problem. So our next task now is to understand this text and to simplify it to the point that we can convert it into code, okay? And a good intermediate step before jumping into the code is to write some notes, and we can use the SQL commenting feature for that. So what I understand from this text is that users make purchases and we're interested in users that make additional purchases. We're interested in users who make additional purchases thanks to this marketing campaign. How do we define additional purchases? Additional purchase is defined as, and the fundamental sentence is this one: users that made one or multiple purchases on the first day do not count. So additional purchase happens after the first day, right? Nor do we count users that over time purchase only the products they purchased on the first day. So the other condition that we're interested in is that it involves a product that was not bought the first day. And finally, what we want is the number of users. So get the number of these users. That should be a good start for us to begin writing the code. So let us look at the marketing campaign table again, and I remind you that each row represents a purchase. So what do we need to find first in this table? So we want to compare purchases that happen on the first day with purchases that happen the following day. So we need a way to count days. And what do we mean first day and following days? Do we mean the first day that the shop was open? No, we actually mean the first day that the user ordered, right? Because the user signs up, does the first order, and then after that the marketing campaign starts. So we're interested in numbering days for each user such that we know what purchases happened on the first day, what purchases happened on the second day, third day, and so on. And what can we use to run a numbering by user? We can use a window function with a numbering function, right? So I can go to my marketing campaign table and I can select the user ID and the date in which they bought something and the product ID for now. Now I said that I need a window function. So let me start and define the window. Now I want to count the days within each user. So I will actually need to partition by user ID so that each row only looks at the rows that correspond to that same user. And then there is an ordering, right? There is a sequence from the first day in which the user bought something to the second and the third and so on. So my window will also need an ordering. And what column in my table can provide an ordering? It is created at. And then what counting function do I need to use here? Well, the way to choose is to say, what happens when the same user made two different purchases on the same date? What do I want my function to output? Do I want it to output two different numbers as a simple count, or do I want it to output the same number? And the answer is that I want it to output the same number because all of the purchases that happened on day one need to be marked as day one. And all the purchases that happened on day two need to be marked as day two, and so on. And so the numbering function that allows us to achieve this is rank. And if you remember, ranking works just like ranking the winners of a race. Everyone who shares the same spot gets the same number, right? And this is what we want to achieve here. So let us see what this looks like now, and let us order by user ID and created at. Let us now see our purchases. Now, user 10 started buying stuff on this day. They bought one product and the rank is 1. Let us actually give a better name to this column so that it's not just rank. And we can call it user day. All right. So this user ID 10 had first user day on this date and they bought one product. Then at a later date, they had their second user day and they bought another product, and then they had a third. Now, user 14 started buying on this date. This was their first user day. They bought product 109. And then the same day, they bought product 107, and this is also marked as user day 1. So this is what we want. And then at a later day, they bought another product, and this is marked as user day 3. Remember, with rank, you can go from 1, 1 to 3 because the spot marked as 1 has eaten the spot marked as 2. That's not an issue in this problem, so we are happy with this. Now, if we go back to our notes, we see that we are interested in users who made additional purchases, and additional means that it happens after the first day. And how can we identify purchases that happened after the first day? Well, there's a simple solution for this. We can simply filter out rows that have a user day 1. Right? All of the rows where the user day is 1 represent purchases that the user made on their first day. So we can discard these and keep only purchases that happened on the following days. Now, I don't really have a way to filter on this window function because, as you recall from the order of SQL operation, the window function happens here and the where filter happens before that. So the where filter cannot be aware of what happens in the window function, and the having also happens before it. So I need a different solution to filter on this field. What I need to do is to use a common table expression so that I can break this query in 2 steps. So I'm going to wrap this logic into a table called T1, or I can call it purchases for it to be more meaningful. And if I do select star from purchases, you will see that the result does not change. But what I can do now is to use the where filter and make sure that the user day is bigger than 1. And if I look here, you will see that I have all purchases which happened after the user's first day. But there is yet one last requirement that I have to deal with, which is that the purchase must happen after the first day, and it must involve a product that the user didn't buy on the first day. So how can I comply with this requirement? Now, for all of the rows that represent a purchase, I need to drop the rows that involve a product ID that the user bought the first day. So if I find out that user 10 bought product 119 on day 1, this purchase does not count. I'm not interested in it. So how can I achieve this in code? I'm already getting all the purchases that didn't happen on day 1, and then I want another condition. So I will say and product ID not in, and here I will say products that this user bought on day 1, right? It makes sense. So this is all the filters I need to complete my problem. Show me all the purchases that happened not on day 1, and also make sure that the user didn't buy this product on day 1. So what I need to do is to add a subquery in here. And before I do that, let me give a alias to this table so that I don't get confused when I call it again in the subquery. So this first version of purchases that we're using, we could call it next days because we're only looking at purchases that happened after the first day. Whereas in the subquery, we want to look at purchases, but we're interested in the ones that actually happened on day 1. So we could call this first day. And we can use a where filter to say that first day, user day needs to be equal to 1. So this is a way that we can use to look at the purchases that happened on the first day. Now, when we make this list, we need to make sure that we are looking at the same user, right? And to do that, we can say And first day user ID needs to be the same as next day's user ID. And this ensures that we're looking at the same user and we're not getting confused between users. And finally, what do we need from the list of first day purchases? We need the list of products. So let me first see if the query runs. So it runs, there's no mistakes. And now let us review the logic of this query. We have purchases, which is basically a list of purchases with the added value that we know if it happened on day 1, on day 2, on day 3, and so on. And then we are getting all of these purchases, the ones that happened after day 1. And we are also getting the list of products that this user bought on day 1. And we are making sure to exclude those products from our final list. And this is a correlated subquery because it is a specific SQL query that provides different results for every row, that must run for every row. Because in the first row, we need to get the list of products that user ID 10 has bought on day 1 and make sure that this product is not in it. And then when we go to another row, such as this one, we need to get the list of all products that user 13 bought on day 1 and make sure that 118 is not in those products. So this is why it's a correlated subquery. And the final step in our problem is to get the number of these users. So instead of selecting star and getting all of the columns, I can say count distinct user ID. And if I run this, I get 23. Checking, and this is indeed the right solution. So this is one way to solve the problem, and hopefully it's not too confusing, but if it is, don't worry, it is after all an advanced problem. If you go to solution here, I do think, however, that my solution is a bit clearer than what StrataScratch provides. This is actually a bit of a weird solution, but that's ultimately up to you to decide. And I am grateful to StrataScratch for providing problems that I can solve for free, such as this one.